Okay, welcome to our continued journey on double replacement reactions. And I want you to look at the three reactions you see up there. You may recognize them from startups we've had or from one of our labs. And what do you notice about the products? Well, hopefully you said, hey, there's a precipitate or there's a solid in every one of those. Okay, and what we're going to try and do is get to the point where I'm going to give you just the reactant, so you'd get just this chunk right here. And I would say predict the products and tell me which one is going to be the precipitate. And we can do that with some solubility rules. Now, what does solubility mean? Well, if something is soluble, okay, that means it dissolves. Okay, and then if it's insoluble, that means it will not dissolve in water. So whether you're taking these things and you're dumping them in water and trying to stir them up and dissolve, or you're making a product and it's in water because it was two aqueous solutions, these things won't dissolve. So what we're going to do is we're going to look at some rules and try and see how it's not too tough to predict what would be the precipitate. So here are the rules right here. If you go online, you'll find them printed right there, or you can just pause the video and write these down in your journal. But either way, you want to get these in your journal. Now this looks pretty intimidating, but I just want to say this. If you really focus on these top two right here, the always soluble list and the generally soluble list, then you really don't have to worry too much about this list right here, because these guys kind of overrun everything. So the first thing I want to point to is if I have a compound that has an alkali metal in it, that compound, no matter what it's attached to, no matter what anion is attached to, is always going to be soluble. So if we look back at the page before, let's find the alkali metals. Look at that. There's potassium. It's aqueous. There's sodium. It's aqueous. There's sodium again. It's aqueous. Okay? So whenever a group 1 metal is involved, it's going to be a precipitate. So it could be cesium, bromate or something like that. Okay? It could be something like cesium, or we could have lithium oxide. It doesn't matter what it's attached to. If you have an alkali metal, that will be a soluble compound. So another cation that's really important to focus on is ammonium right there. Okay? It doesn't matter what compound I have. If I have ammonium NH4, I'm going to put a parentheses around here, dichromate. This one seems to pop up quite a bit. If I have ammonium dichromate, ammonium sulfate, okay, if you see ammonium, you immediately know that your compound is going to be soluble in water, right? So those two really help out. Probably the biggest one for the anions is a nitrate. You're going to see lots of nitrate compounds, whether it's just lead nitrate, okay, lead nitrate, potassium nitrate, iron 3 nitrate. Okay, it doesn't matter what you see. If a compound has a nitrate, that compound will be soluble. So let's look at our reactions over here. Okay, get some of this out of the way here. Okay, let's look at, there it is, there's one right there. There's a nitrate, it's aqueous. There's a nitrate, it's aqueous. Okay, so if nitrates are involved, you're going to have a soluble solution. Really important. Okay, so we go back to the other one. Now the other ones that I have here, chlorate, perchlorate, and acetate, those are also always soluble. We just don't see them very often, but we will look at them once in a while. But if you see those, you have a soluble solution. Now what we want to do is we want to get to the ones that are mostly, not mostly, the ones that are sometimes soluble. Okay, and that's this group right here. Okay, and most of the time they will make a solution. For example, you guys know about this. You take that, dump it in water, stir it up. What do you have? Well, it disappears because table salt is soluble in water. Maybe something like this, potassium iodide, soluble in water. I could take something like a copper 2 iodide, or I don't know. How about a nickel bromide? Okay, all those are going to be soluble. However, the halides, at least chlorine, bromine, and iodine, they will make a precipitate only if combined with 3 ions: silver, lead, and mercury. And that's important to remember. Now, this section right here, I can tell you, confuses people. So we've got a simple mnemonic that will help you remember. Okay, what are the 2 toughest classes in high school? AP classes and honors classes. So we've got the mnemonic APH. If you can remember the halides are APH, you will be able to remember this. So if I see something like this, AgCl, that will make a precipitate. Okay, Pb, Br2, that's a precipitate. Mercury 2 iodide, okay, that's a precipitate. But that's the only time those are precipitates. Okay, the fluorine, I'll be honest with you, we don't really see fluorine pop up too much. The other addition, though, is lead and magnesium. So that's why we've added a PM to our CBS. But let's go to this last one, because sulfates pop up all the time. Now, most sulfates are soluble, except if you have these 4 ions. Okay, and so the mnemonic for this is, I think, TV, CBS, PBS. So there you go. There's your mnemonic for the sulfates. So let me ask you this: Na2SO4, soluble or insoluble? Exactly, it is soluble, right? One of the reasons it's a group 1 metal. The other reason it's not one of those 4. Okay, let's draw this. How about this one? SR-SO4. Soluble or insoluble? Right, the answer is insoluble, because that is the S in PBS. How about this? Copper 2 sulfate. Exactly, the answer is it is soluble, because it's not one of those 4 down there. Okay, so that's really how we play with this. Now, how does it work with all these things that are generally insoluble? Well, to be honest with you, if you know these top 2 rules, you can get through most of this. Because you might want to try and remember that carbonates, phosphates, sulfites, oxalates, chromates are insoluble, but it's much easier just to remember the rules about sulfates and the halides, and then have these down. And then everything else is insoluble, except, just like it says right here, with alkali metals and ammonium. All right? So now that we have a general idea on the solubility rules, let's see how we can put this to use. Okay? I've got a couple reactions here, and what I want you to do, actually, you know what? I'm going to do the first one for you. So let's look at the first one. Oops, didn't mean to do that. All right, so we've got equal concentrations of potassium carbonate and bismuth 3 nitrate. Okay, so as you can see from the directions there, it says predict the products and balance the equation. Use the solubility rules to write the net ionic. Okay, so K2CO3 plus BiNO3, 3. Okay, now again, these are all double replacement reactions, so I'm going to make some potassium nitrate. And bismuth has got a +3 charge, so it's Bi2CO3, 3. All right. The thing to remember, because a lot of the times you guys are writing these formulas incorrectly, is we write the formula correctly first, and then we balance it. We're writing the formulas to make sure that they are ionically neutral, and then we are balancing it. I've had a number of people today want to write K2NO3, 3, and that, of course, is not going to form. So now that I've got that, let's see. I've got 3 nitrates there. I'm going to put a 3 right there. Oh, I can change that right now. I can see that's already going to be an issue. Okay, oh boy. How about my 3 carbonates? I'll put a 3 right there, a 6 right there, and a 2 right there. Okay? So now it's balanced. Now let me ask you this. Of the two products here, which of these two is going to be a precipitate? Well, let's look at this one. There's a group 1 metal, and there's a nitrate. Both of those are soluble. That's almost like a doubly soluble thing. And then we've got carbonates. Do I know the rules about carbonates? Not really, but I know it's not a group 1 metal here, and it's not attached to ammonium. So this thing must be our precipitate. So now I'm going to write my net ionic equation. So I'm going to write 2Bi. Remember, it includes only the ions that are involved in the reaction. And 3 carbonates. And again, don't forget, we've got to include the charge because it's a net ionic. Bi2C. Oops. Sorry, my parentheses threw me off there for a second. CO3, 3. Okay? So there's your net ionic equation. Okay? So now take a moment. Try this one. Made it a little tougher on you because I have not given you the formulas for the two compounds. So take a moment, pause the video, and then see if you can do it. Okay, did you do that? Hopefully you did. Let's write this out. Okay, I've got CaNO3 plus aluminum fluoride, AlF3. It's a double replacement, so I'm just going to switch the ions. Calcium is going to combine with fluorine, CaF2. Okay, plus AlNO3, 3. All right. So let's go ahead and balance this thing. I've got, I'm going to put a 2 here. Pardon me, I'm going to put a 3 here, a 2 here, a 3 here, and a 2 here. All right, so now we've got a balanced equation. Now my question is to you, what is the precipitate? Well, look over here. There's a nitrate. Nitrates are always soluble, so that's not a precipitate. So this one right here must be our precipitate. And if you look on the previous list, our solubility rules, for fluorine, right, calcium right there, CbSpm. Okay? So now that I've got that, I'm going to write out the net ionic. So 3 calcium, 2 plus 6F minus yields Ca3CaF2. And there you go. Wrote out the net ionic equation. Okay? Okay, do the last one. Pause the video, try it all by yourself, see if you get what I get. Alright, hopefully you've done that one. Here we go. Lead 2 nitrate, PbNO3. Now hopefully you can see why this is a solution, because it's a nitrate, right? And then potassium iodide, and hopefully you can see why that is a solution, because there's a group 1 metal. Okay? We're going to mix them. We're going to get PbI2, kind of a neat yellow precipitate, and some KNO3. And then we're going to go ahead and balance this. Okay? So now you've got that. Which of the two is our precipitate? Well, there's a nitrate, and there's a group 1 metal, so that's not going to be a precipitate. So we're going to get a precipitate right here. Okay? So now I'm just going to write the net ionic equation, including the ions that are involved. Oh, you know what I did? I failed to balance this thing correctly. If you were yelling and screaming at the monitor, I appreciate the help. All right, PbI2. Okay, so there you go. A little quick and dirty explanation of writing double replacement reactions, predicting the precipitate with solubility rules. And again, we're going to practice this for a while. If you have any questions, come